Okay, so in this experiment we are going to look at a phosphorylase assay, and your students can adapt this for whatever independent variable they wish. In this reaction we start with our substrate glucose 1-phosphate, which in the presence of starch phosphorylase will be converted to starch. In this method, there are 4 main stages. We extract the enzyme from potatoes, we carry out the phosphorylase assay, and then at advanced higher level you might want to carry out a standard curve and then use that to determine the concentration of starch that was produced in the assay. To extract the enzyme from potatoes, you start with this list of materials here, and you need about 50 grams of chopped potato, and you're going to blend that in the blender with about 20 ml of water to form a slurry, which you can see in the top left hand corner. So this gives us an overview of the whole step 1. So we form that slurry, and then we're going to transfer all of the contents of that blender into a bit of muslin, and we're going to squeeze that through into a beaker, and we're going to capture all of that almost supernatant, that filtrate, and we're going to then collect that into these centrifuge tubes, and we're going to balance those nicely, so the same volume in each one, and then we're going to centrifuge that at about 6,000 RPM to pellet out the starch granules. So the whole point of that is to get rid of any big starch clumps that might be there, with our enzyme held in that supernatant. And we're going to test that supernatant for the absence of starch by drawing out a little bit, mixing it on a dimple tile with some iodine, and we're just double checking that there's no blue-black colour. So here we'll see in the dimple tile that there was no blue-black colour in those top left dimples. So now we're happy that we've prepared that enzyme appropriately. So we're going to move on to stage 2. And in stage 2, we need a range of different materials, which includes our substrate glucose 1-phosphate. These are the different materials we're going to need. And we're going to start by putting in 7 cuvettes into the rack, adding 1 with 3 ml of water, and then cuvettes 2 to 7 with 1 ml water, 1 ml iodine. We're then going to collect 2 test tubes, put them in the rack, and to test tube 1 we're going to add 1 ml enzyme and 1 ml water, and to test tube 2 we're going to add our 5 ml enzyme and then 5 ml glucose 1-phosphate and immediately start the stopwatch. After this point, we're going to be regularly taking 1 ml samples from that second test tube and adding it into our cuvettes. After every 60 seconds, we're going to repeat that process, and that's shown here. So from our test sample that has our enzyme and substrate, 1 ml out, and then mixing that into our pre-prepared iodine mixtures in the cuvette. After that assay, we're going to look at the absorbance of each of those solutions. And you can see over that time course, we have more blue-black colour, which indicates starch is being produced. Using colorimetry, we're going to blank the absorbance reading with a cuvette of water. And then we're going to be measuring the absorbance of that colorimetric blank, which gives us the absorbance reading contributed by the enzyme preparation on its own. And this will then be subtracted from all the values, all the absorbance readings that's generated from all of the assay reaction points at each 60-second interval. And this is what they will look like here. This is an example of a results table that you might generate from that data. And you can see that we've got our mean values over 3 triplicate readings, and then our background, our colorimetric blank, has been subtracted from those, which gives us our corrected mean. And now we're going to move on to stage 3, which is where we're going to do a standard curve for starch. So we need this range of materials and those working concentrations of starch so that we can prepare this dilution range from 0 to 0.03 mg per ml of starch. So what we're going to do is set up 8 cuvettes. We're going to add 3 ml of water to the first one, and then to cuvettes 2 and 8, 2 all the way through to 8, we're going to add 1 ml water and 1 ml iodine. And then from each of those we're going to add 1 ml of the respective starch suspensions that we have prepared, so that we can then measure the absorbance of each of those. So this is the absorbance that we will generate with a known concentration of starch. And from that, we generate this range of absorbance values, and we're going to plot that as a calibration or a standard curve. So this fits nicely into the curriculum, but it also is a really excellent next step for a student doing something like this as part of an advanced higher project. Now, what that standard curve will give you, if you plot it on Excel, is the equation of that line. And that equation will then be used in stage 4 to determine the concentration of the unknown starch that was produced during stage 2 when they carried out their assay. So they have got these values perhaps up the top, these corrected mean values, but what does that actually mean in terms of the concentration of starch produced? So they can do a bit of substitution with that standard curve equation, and they can determine how much starch was actually produced in that reaction, and just translating the absorbance values for an actual starch concentration. And then they could plot those values, so over that time course, how much starch was produced as a result of starch phosphorylase reaction in that synthesis reaction that the student studied. And they can vary, instead of looking at a time course, they might look at a particular independent variable and its impact on that reaction.